Before diving into the technical details of the features we have built, let me explain what I mean by identity and authentication and why we do things differently on the internet computer than on the traditional web. When you log into a website today, you're likely asked for a username and password. Your username, nowadays most often your email address, serves as your identity, the unique identifier that connects all the data on the servers to you. Your password is the means of authentication. Since only you should know your password, the server takes your ability to enter the password as a proof that it is communicating with you. It turns out that passwords, despite their wide use, are actually not a good mechanism for remote authentication. We'll touch on some of the reasons later, but I want to start with one right now. When you enter your password on a website, your computer sends the password to the server, where it is checked against the password database. If you follow IT news, you've certainly seen lots of headlines about attackers extracting the password databases from company A or service provider B. The passwords are not necessarily stored in the clear. If they are, such an event is of course catastrophic. But even when industry best practices are followed, such as only storing a so-called salted hash of the password, recovering passwords from such a user database is only a matter of computational and thus monetary resources that an attacker is willing to invest. The internet computer is designed to provide security against malicious behavior of individual compute providers by replicating data and computation across multiple data centers. Replication, while protecting the integrity of the data, does not protect against leakage of information, and thus the use of passwords on the internet computer would still be subject to the same security issues as on the traditional web. Thus, we replace passwords by proper cryptographic authentication. The main cryptographic mechanisms we use for authentication on the internet computer is a digital signature scheme. Digital signatures are a pretty standard concept. They have been invented in the late 70s and are widely used at least since the mid-90s. They are generally thought of as consisting of three algorithms. The first one is key generation, which you can think of as an analog for choosing a password. Key generation creates a pair of keys, a private key that has to be kept secret, just like a password, and a public key that is derived from the private key but can be made public. The second algorithm is signing. It takes a message and the private key and produces a signature. When we use digital signatures for user authentication, this algorithm is run on the user side where the private key is held. The third algorithm is verification. It takes the message, the signature, and the public key and verifies whether the signature matches the message and public key. The crucial property here is that, unlike when checking a password, which requires the secret password in the clear on the server, the verification of a signature can be performed merely on public information. The server stores a list of public keys, one for each user, and neither the public key nor the signature have to remain secret.